Okay, so what I wanted to do today was briefly go over how to find the limit of some sort of function as x approaches infinity. And notice this is approaching positive infinity, not negative infinity here. And this function is pretty much just, it has a string of terms on the numerator and a string of terms in the denominator. So there's kind of a method that you want to follow, and we went over this in lecture, but I just want to reiterate kind of what's going on here. So you have the limit of 4x squared plus 5x plus 2 over 2x squared minus 3 as x approaches infinity. Okay, so I don't know if you remember this, but we were talking about what you do when x is approaching infinity. You divide each term in the function by the term with the highest exponent. So in this case, the highest exponent is x squared, right? That means that you are going to be dividing each term in this function by x squared, every single one. And then after that, things are going to cancel out, and it's going to look a lot nicer for you. So let's go ahead and do that. Now, please remember that when you're doing these problems, make sure you always keep the limit sign. That's really, really important. If it was on a final or something like that, we would take points off for that. So, okay, we have 4x squared divided by x squared plus 5x divided by x squared plus 2 divided by x squared. Literally all we did was just divide by x squared for each term. And then on the bottom we have 2x squared divided by x squared minus 3 over x squared. Okay, so that's pretty straightforward. But now what we have to do is cancel a few things out and look at something a little bit conceptually here. So we know that 4x squared divided by x squared is just 4, right? Because the x squareds cancel out. And 5x over x squared, well, x squared is x times x, right? So if we have 1x on the top and 2x's on the bottom, we just cancel 1 out on the bottom and cancel 1 out on the top, so we're left with 5 over x, right? Okay, and then 2 over x squared, we can't simplify that, so that just stays as 2 over x squared. So I'm going to rewrite this. We're left with 4 plus 5 over x plus 2 over x squared. All right. Now on the bottom, 2x squared over x squared, again, you cancel out the x squareds, and you get 2. And then minus 3 over x squared, that just stays the same. So we have 2 minus 3 over x squared. Okay. Now I just want to point out one little side note here. So whenever we see a variable, such as x, or x squared, x cubed, whatever have you, and they're approaching infinity, all that means is that your denominator is going to just be getting really, really, really large, okay? And when your denominator gets really, really large, that entire fraction, that entire expression gets really, really, really small, and it eventually tends towards 0. And I'm going to show that a little bit right here. So let's say we'll take 5 over x for instance. We have 5 over 1, and then it goes to 5 over 10, 5 over 100, 5 over 1,000, 5 over 10,000. Okay, so what's happening is the x on the bottom is getting increasingly larger. It's tending towards infinity, right? But what's happening here is we have 5 here, we have 5 tenths here, which is about 1/2. We have 5 over 100, 5 over 1,000, 5 over 10,000. That means that these fractions here are getting smaller and smaller and smaller, right? So we can say that this entire 5 over x thing is going towards 0, right? And that's true for all of the terms with a variable such as x in the bottom. So we can also say that 2 over x squared is going towards 0, converging towards 0, and 3 over x squared is doing the same exact thing as well. All right, so what are we left with? That's actually going to eventually be our answer, right? So we're left with the limit as x approaches infinity. We have 4 plus 0 over 2 minus 0. What does that become? Well, 4 over 2 or just 2 for short. And I dropped the limit sign because I just got to my answer. So that would be the final answer in this case. The limit as x approaches infinity would be equal to 2. I hope that helped you.